Mars planet, a cold, dusty world where the air is so thin your blood would boil at the smallest hole in your suit. It is beautiful and deadly. We have seen billion-dollar plans and billionaire dreams. India's way is different, efficient, clever, and built to do more with less. This is not a fantasy. This is a survival guide. Now we will cover the why, the how, and the uniquely Indian solutions that could actually keep humans alive on Mars planet. From expandable homes covered in Mars soil to the growing Indian dishes under LED lights, this is how ISRO might make a colony work. Remember Mangalyaan mission. ISRO reached the Mars planet on a very small budget, cheaper than many movies. That mission proved something vital. India can hit big space goals efficiently. Now imagine moving from orbiting stage to the landing stage and then staying. That step is huge. Getting there is a one problem and surviving is a 1,000 times harder problem. ISRO's approach is low-cost innovation. That means using smart ideas over raw power, such as clever designs, systems built from pieces, and reusing everything. That is how a country with limited budgets stay competitive in deep space. So what would we need to survive? Homes, air, water, food, power, and a way to handle the loneliness. Let us start with home. Home, the expandable living module. The home on Mars planet is basically a pressure balloon you must live inside for months. Shipping stiff buildings is expensive, so expandable, packable homes make this sense. ISRO would likely to use small modules packed into a lander, then opens them on the Mars ground. Expandable skins gives you the space, inner flames gives you the strength. They are cheap to launch and fast to set up. But the radiation is the real killer. The solution is the local soil. Robots would cover homes in Mars soil to form a protective blanket. It is like covering your house in sand to stop cosmic rays. India already tested 3D printing for the moon. On Mars planet, a mix of expandable cells and 3D printed soil walls could be the simplest, cheapest shelter. It is practical, can be printed on site with local soil instead of shipping tons of material from Earth. Essentials: air, water, and food. Air comes first. We must make breathable oxygen before anything else. Mars CO2 rich air can be turned into oxygen. NASA tested MOXIE on Perseverance rover to prove it works. ISRO would need a low power, tough version for its smaller power limits. As we know, water is life. Mars planet stores ice at its poles and under the surface. An ISRO mission would likely pick spots with easy to reach the ice, dig a bit, melt a bit, and recycle almost everything. Growing crops to prepare food for humans is tricky because Mars soil is toxic and shipping fresh food from Earth is costly. The solution is to make soil-free farming and closed cycles recycle water and nutrients. Scientists are thinking to grow fast-growing crops such as leafy greens, potatoes, and herbs. And yes, scientists are already thinking to grow Indian dishes including dried dals, spice mixes, and instant Indian meals adapted from Mangalyaan menus could work. Every scrap on Mars planet counts. Waste becomes fertilizer, human waste becomes raw material, and they are spent plant matter cycles back to soil or fuel. An ISRO colony would depend on near total recycling. Nothing becomes trash. Power and communication. Power is life support. Mars planet gets less sunlight and dust storms can darken everything for weeks. Creating big solar flames are possible but not reliable. That's why small nuclear reactors with compact, safe designs are attractive. They provide constant power when the sunlight fails to reach the Mars planet. ISRO has been careful, but a future colony would likely use a mix that is solar plus small nuclear backups. Communications from Mars planet to Earth are slow. It takes about 20-minute delay each way. You can't call a mission control for every problem. That means the colony must be able to act without waiting. Autonomous systems and AI would run daily life for switching power, sealing leaks, and finding faults. The human crew focuses on plans and repairs while AI handles immediate threats. Think of it like having a very capable local co-pilot. The human factor and Indian culture on Mars. Surviving is not just physical, it is mental. Food, traditions, and connection matter. Little things, spice mixes that smell like home, short video calls, and shared festival becomes lifelines. Imagine celebrating Diwali under LED stars or a crew member teaching others to make a masala chai in a small gallery. These cultural anchors keep morale high and make a colony feel like a home, not just a lab. Mental health care, routine exercises, and group support will be as important as oxygen. ISRO's approach would be low cost but carrying simple tools that preserve dignity. The conclusion: start small, build a science outpost, and use local resources. ISRO using materials found on Mars planet says over decades, modules expand, factories use local materials, and a self-sustaining settlement becomes possible. ISRO's strength is low cost, clever ideas. That's the fastest path to staying on Mars. It won't be glamorous, but it will work. And when India sets its goals on the stars, cleverness follows. What would be the hardest part for you? Food, isolation, or the 20-minute wait for replay? Tell me in the comment section below. Hit a like to this video, share this video with your fellow space lovers, and don't forget to subscribe to Galaxora and turn on notifications.